All right, let's get started. My name is Carleton Miyamoto, and with Michael, I'm going to be talking about how we use Couchbase at LinkedIn. I'm going to talk a little bit about LinkedIn, who we are, what we do, and then I'll talk a little bit about Couchbase and some of the tools and infrastructure that we built around Couchbase at LinkedIn. So my name is Carleton Miyamoto. I'm a senior staff software engineer at LinkedIn. I work for the Marketing Solutions Division, and I'm one of the architects there. I'm also one of the engineering representatives to the Couchbase virtual team, which is the internal team at LinkedIn that deals with Couchbase and advises others on Couchbase usage. So who are we? LinkedIn was founded in 2002. It was founded as a professional social network, and it has since grown to be the world's largest. We have offices in 24 countries and available in 23 languages. Our Q2 2014 revenue was on the order of 500 million or so. So that's the size of what we deal with every day. So as LinkedIn has progressed through its stages, it has grown quite significantly. Right? There are tons of site features at LinkedIn, whether you talk about member profiles, connections, sharing, applying for jobs, shares, company groups, company pages themselves, and a bunch of premium tools that are wrapped around LinkedIn for hiring, for jobs, for marketing, for salespeople. All these features have sort of grown organically over the years and have gained a lot of acceptance. And we've also experienced a huge growth in internet traffic over this time. So we get billions of hits per day. Right, it's a lot of traffic that comes through, and you have to go and you have to deal with all of that traffic. Our audience especially has grown, 300 million plus members and growing every day. 3 million plus company pages, so companies come to LinkedIn, create pages, create marketing sites on LinkedIn. And 2.1 million groups, so lots of people create their own custom groups to talk about things and to get like minds together. So lots of scaling, lots of growth in traffic. So what happened at LinkedIn is that we basically outgrew our storage systems. Right? Whether you have an Oracle, whether you have any sort of database, you just cannot take that kind of traffic through a database. Right? So read scaling became a huge, important aspect for us. We basically use caches. We replicated entire databases into memory. We have a bunch of temporary data. So for example, we do a lot of deduping from time to time. And so we need temporary data to do deduping within certain window frames. And we basically had, in the beginning, used a bunch of technologies, memcached, ehcache, and we built custom caches as well. And on top of this, we built a lot of infrastructure around storage systems to deal with this caching. So cache invalidations, for example, is a very difficult problem. And we built a special infrastructure for that and reliable data replication as well. So whether you're from Oracle, if you do MySQL at this point, we have ways to replicate the data so that we don't miss anything. So we've built all of that in-house. So now, as the number of servers increased, caches on an individual server, of course, become pretty untenable because you have a lot of data on a server. You're restricted to certain types of load balancing if you have a lot of data and partition them onto single servers. And so at some point, we focused more on remote caches. So we would have remote caches that would cache a lot of the data, and that would allow our front ends to partition in any which way they wanted to and which made sense for them. So our back ends basically became agnostic of that. Now, for us, it's important for our caches to keep warm. And one thing that we do is that we built a lot of operational tools and standards to help to keep our caches warm. So whether it's configuration scripts, certain patterns for deployment, support libraries for our developers, monitoring of the servers, they're all tuned to keeping our caches warm and making sure that we stay up and in a servable state. I'll talk a little bit more about that later. So as we use memcached more and more, there's some limitations to it. So if we had to come from a cold start, we basically had to seed the data in memcache, and that, of course, takes a long time. If you have thousands of rows, it's not a problem. If you have millions, tens of millions, hundreds of millions of rows, it's a problem. It takes a very long time to actually load all of that data into memcache. We wrote our own partitioning layer. So we have multiple memcaches partitioned. We have built a partitioning layer on top of that with their own partitioning logic. And that's something that we have to maintain, that we did not want to maintain going forward. And of course, if the memcache goes down, server gets rebooted somehow, that cache becomes cold. And once that cache becomes cold, we see more traffic to our databases. We may, in fact, see some errors come up on the site because the database gets overloaded or various other reasons. And so that's a bad thing. That's a very bad thing. And of course, difficult to move data across data centers with memcache. There is no support for that. On top of, again, usually a very old version of memcache. So we decided at some point that we wanted to move off of memcache into something else. We looked at a bunch of systems, including Mongo and Redis, and eventually settled on Couchbase. And now there are certain reasons why we did this. Couchbase definitely has some advantages. It has a memcache built into it. It is basically a memcache protocol. And so it is something that we are familiar with. It's something that we could, that our operations understood, and we could put it into our memcache clusters and simply replace them with Couchbase and have a reasonable expectation that it would perform similarly. Of course, built-in replication and cluster expansion. This is very difficult with memcache, especially with our partitioning scheme, which we had built, which was not that great. And so with replication cluster expansion with memcache, with Couchbase, it became much simpler to manage these clusters going forward. And of course, memory latency, asynchronous write disk, and we already had a bunch of development infrastructure that we could utilize for this. So Couchbase was sort of a natural fit into what we're doing. So partitioning as well. The partitioning is done automatically, and rebalancing of a cluster. I really love that you can single point and click rebalance. It's a very nice feature. So warm caches. So we use replication to make sure our caches stay warm. Essentially, we have replicas of our caches. And that way, if any one machine goes down, we still have the cache. And it's still warm, and it can still serve traffic, and we don't go down. And of course, we do rely on writing data to disk, just in case the servers get rebooted, just in case we lose a bunch of servers. But it's still there. So once we bring it up, it comes up, reads the data from the disk, and we have warm caches again. It takes longer, but it is something that allows us to sleep at night, if I should say. And of course, the backup and restore and live data pumps for data transfer across data centers, especially for backing up, for when we bring up new data centers to move data to different data centers and make sure that the data centers come up with warm caches. We love those features of Couchbase. So let me tell you a little bit about what we do for development. So we've built some new tools around Couchbase. We've created things to allow developers to have a simple transition from memcache to Couchbase. And we have backup and restore processes as well. So the way we had used memcache at LinkedIn was we had Spring. I don't know if you've seen Spring before, a bunch of XML, which instantiates objects. And we have a Java interface, which is essentially a caching Java interface. And everything was coded to that interface. So whether in the past we had used memcache, ehcache, custom cache, we would implement that interface for caching. And so when it came to Couchbase, all we had to do was implement that interface with the Couchbase native client. And with Spring, it was simply as simple as changing some of the parameters, changing the class that gets instantiated, and boom, you're using Couchbase. It was very simple for our developers to adopt that. There are basically no Java changes that had to be done. So we tend to configure Couchbase to size with memory. So again, these are services that we had moved from Memcache to Couchbase. And so by simply sizing the Couchbase to memory size, we get the same performance as we did with Memcache. And again, quick rollout, understood behavior. That's the key to this. We understood the behavior of Couchbase. We knew how it was going to act. We tried it with both small and large services, and it acted like how we expect it to act, basically. So that was a huge advantage for us in rolling this out. And of course, we use all of the features specific to Couchbase as well. So another thing that we've done is we've done some integrations, some loose integrations with Hadoop. So one thing to realize is that to keep our caches warm, we can do it online, or we can also do it offline. Right? So we have Hadoop jobs that will go and essentially build our caches offline. Create files. We have some tools that will actually create different files and put them into different partitions of Couchbase. So we only have to load up what's in each partition locally to the machine. And so we can then take those files, load it up into Couchbase, and once they come up, apply any deltas that happen since we actually took the snapshots. And again, we have clean, warm caches ready. And doing this is, of course, much faster than if you had to build it straight from a database yourself and go through any routing layers. And we do a bunch of aggregations as well and some data manipulation. And so doing this offline saves us a whole lot of time, and it allows us to bring up our caches much more quickly. So we have approximately 10 or so services, multiple clusters per service. I think somewhere on the order of, I believe, 60 clusters, I think it was, of Couchbase running at LinkedIn. We have multiple data centers as well, so the clusters are spread out across our 3 data centers. A cluster may be up to 100 servers, so decent-sized clusters, and both single and multi-tenant. Now, let me talk about some of these systems. One system is the follow system. So if you've gone to LinkedIn and followed something, right? We actually have multiple follow systems. This is one of the following systems. This follow system has about 70 million or so follows. So in a database, it would basically be 70 million rows, right? And we built it to scale initially a while ago using Memcache. And we transitioned it to Couchbase. Couchbase holds all the data, handles all the queries. And the transition was fairly fast. So looking at some of the numbers here, these are the latencies for the servers. And what you're seeing here is a 99 percentile graph. So 99 percentile is up there, usually. It's the outliers, right? So, and our 50 percentile graph is actually much better than this. But if you look at the 99 percentile, and if you compare it to other graphs that tend to be in the 99 percentile, this is fairly good, right? If you look at it, it's fairly flat, it's fairly consistent, you have very low variance, and this is what you want to see in a service, right? You don't want a lot of variance when you're serving a lot of this data. You want it to be flat, you want it to be consistent, and you want to understand how it works, and it should work as you expect it to work, and you get the fewest problems that way. Of course, the Couchbase side, this particular cluster has 4 nodes, and we see get about 10 or 11 KQPS on it. Not too bad. We use it for read scaling of our jobs as well. The Couchbase cluster takes about 10,000 QPS, 16 servers. This is where we use Hadoop to pre-build some of the data. And again, the Couchbase 99 percentile latencies. Pretty awesome. So another place that we use it, which is a little more recent, is we have services, and the services all have monitoring metrics. And so those monitoring metrics were served by Couchbase to our metrics UIs. And we've since hooked it up to Elasticsearch, so we can actually do searches on the names of the metrics and various things in our UI. And basically use the transport Couchbase in Elasticsearch and hook it up with XDCR. And it works great. OK, so with that, I'll hand it over to Michael, and he's going to talk about some of the things that we're doing in operations.
So my name is Michael Kehoe. I'm a site reliability engineer at LinkedIn. I'm the SRE for Profile and Higher Education. And obviously, I'm a member of the Couchbase virtual team. So to give a little bit more background on CBVT, basically we're a virtual group, so we're not actually I guess like a formal working team. So I know Facebook and Twitter, they actually have cache teams. We're not, we're a virtual team. So we all belong in our own different SRE and development groups. But we assemble about once every 2 weeks for meetings, and we do a lot of online communication to keep the virtual team going. And so my background is actually electrical engineering from Australia. So as you would have seen over the past 2 days, there are a lot of awesome features in Couchbase, and we basically, from an operations side, want to make the experience for everyone much better. So a lot of people in the team, both past and present, have worked really hard to build a lot of really good tools around Couchbase to make the operational experience really, really good. So as I'll show you a little bit later, we've built SALT modules. So in the room, who has heard of SALT or SALT Stack? I was hoping for a little bit more. So SALT's another basically remote execution framework. So it's sort of like Puppet and CF Engine, but it's more oriented around remote execution than sort of templating configurations, which it can still do. So we've built we've built SALT modules to create clusters, to add, remove servers, and do all our configuration, which I'll show you a little bit later. We're actually now building our own custom RPM, so we can go and backport bug fixes, or we can go and put our own things into an RPM if we so choose. We've integrated with our monitoring dashboards. So in Couchbase 2.2, which is what we're currently running, Couchbase 2.2 emits about 240 metrics. So we've built our own monitoring tools to basically go and gather the stats from the Couchbase cluster and then go and send them into our monitoring tool called Ingraphs. And so we go and monitor things like key to value size ratio. We look at aggregated metrics across the cluster, so things like QPS, and then data and memory size. And I'll show you a little bit more of this later. We also, one thing we do monitor is data ejection to disk. So in most of the talks over the past 2 days, you would have heard a lot about active size or active working set. So we're very particular in our setup that basically everything is kept in memory. So if you get, we have a particular high watermark, and then we start alerting if you're potentially ejecting to disk. We've also written some of our own backup infrastructure. So we've basically wrote a nice wrapper around pump transfer to go and do incremental backups, which sort of is what now 3.0 does. But we can go and basically run scripts, run a script to go and do a backup every day. So we've got those sort of incremental backups when we need them. We also do complete logging of our backup progress, and we also go and monitor the failures on backups and the size of backups. So if we need to go into some complete disaster, we need to go and revert to that backup. We know that it's actually there because we're actually monitoring the backup process when we do it. So Couchbase and SALT. So we use SALT modules and SALT runners just because it fits a little bit better with how we do our security. So from my desktop at work, I can't actually go and log in to the Couchbase web UI. I have to port forward to that, and we don't like doing that particularly at LinkedIn. So using SALT as our remote execution framework, that works really well to allow us to go and perform all the administration tasks that we need to on our Couchbase servers. So we have a SALT module that basically handles adding and removing servers from clusters, doing the cluster rebalance, and then managing failovers. Most of that just happens around maintenance tasks around our servers. So if we need to take one down for a DIMM replacement or a hardware replacement, we can easily do that very quickly in SALT just with one command. I don't need to port forward to production and then log in, et cetera, et cetera. And then we go and we also have a SALT runner, which does installation. It will soon do decommissioning of clusters, and it also does some managing of buckets. And at the end of this year, at the end of Q4, we're aiming to actually open source all of our SALT tooling, which hopefully you'll all really like. So I want to give an example of how we create a cluster. So I'm not going to do this as a demo, but imagine this as a demo. So imagine this is my shell. So I go and set a whole lot of environmental variables. So I'm going to go and create a cluster in production, ELA4, which is one of our data centers. The instance number is 0. So if any of you are familiar with range as the cluster manipulation tool, we use that heavily within LinkedIn. So I'm just setting instance 0. I'm setting the RAM size per box, the bucket name I want to use, the port it's going to run on. The first one was the total number amount of RAM for the cluster, then per host, number of replicas I want, the version of Couchbase I want to install on the cluster. And then I give it basically the range definition of the cluster. And then we also go and fetch the name of the SALT server or the SALT master we're going to use. And then I basically run this one command, sudo salt run couchbase easy install with all my variables. And it builds my Couchbase cluster in less than 2 minutes, completely configured, completely set up. And I'm basically, after that command's done, I'm ready to go, knowing that my server has set up, or my install has set up my servers the way I want, with all my, completely rebalanced, and with replicas running. So it's an extremely, extremely, extremely easy process to go and build a cluster from scratch. So, as I was talking about before, Couchbase natively exposes over 240 metrics in the Couchbase 2.2. So we've built our own custom metrics collection tool to go and retrieve all of those metrics from the cluster every minute and then send them off to our in-house monitoring tool called Ingraphs. And then we go and, for Ingraphs, we can go and build our own custom dashboards. So the Couchbase virtual team has basically built out a standard dashboard that we use for all our clusters. So if anyone goes and looks at a dashboard for any particular cluster, we know exactly what to look for, and we know exactly what we're monitoring, which is really important, especially in an infrastructure as large as ours. We have lots and lots of metrics generated across all of our services. So it's extremely important to know what is the metric you're actually reporting on. So to go and create my dashboard, basically I run this Python script called couchbase.py. I give it a small amount of information. I give it basically the range instance number, and that's it. And then it goes and generates this dashboard. So it's created just for a generic Couchbase cluster, it's gone and created that, and it's easy as that. And then all the metrics are automatically fetched, put into a template, and it also goes and does all of our alert generation. So it generates the alerts for that particular cluster, and they get automatically onboarded into our alerting system. So this is a screenshot of one of our dashboards. So these are sort of the top metrics we monitor. So you can see the green AA circles on these dashboards. So AA stands for auto alerts. And obviously they report green if the alert is okay, or red if there is an alert happening. So we sort of monitor things like QPS. Hit ratio is important, but we don't actually monitor on it, just because you do get sort of edge cases where we have things like hotkeys. So it's sort of difficult to create standard monitoring around that. We look at percent of items in memory. So as I said before, we basically want everything in memory. If you're ejecting to disk, you need to upgrade the size of your cluster. We also look at percentage of memory full, so both for the cluster and for the host. We look at high watermarks. Another thing is actual replicas. So we always want to make sure we have a replica in case we lose a host. And there's 1 or 2 other metrics that we report on. So I'll pass this back on to Carleton to finish up.
Thanks, Michael. So just to sort of wrap this up, Couchbase actually was a very nice fit for our existing infrastructure. It was very easy, and we've built our processes and tools around it to make it easy to actually transition from Memcache to Couchbase. We're seeing read scaling, and you've seen some of the graphs. Latencies are very good. And we've built a whole bunch of management and monitoring around these clusters. So part of running a service 24/7, and it really is 24/7, meaning that because we get traffic from all over the globe, we actually do not have downtime. And so being able to monitor these servers and manage them in real time is actually extremely important to us. And we do watch these graphs very closely. And it's not just our tooling, but it's Couchbase's rich tooling that comes with it that allows us to look at it, to extend it sometimes even, that actually helps a whole lot as well. So looking forward, we are continually looking to improve this cold and warm start times. I think, especially with Couchbase 3, with some of the enhancements to XDCR, I think we're going to be looking closely at that to see how we can utilize some of that in the future. All right, so with that, field any questions? Yes?
So number of servers you said up to 100 cluster, correct? So
yes.
What is the size of the server configuration?
The servers are, do you have the server stats?
64
gigs of memory.
So it depends, either 64 or 48 gig, and we leave 8 gig for the OS. So it does depend. There's a number of clusters that don't even need that, amount of memory, so it depends.
Yes?
Do you use cross data center replication currently? And also, how many replicas do you typically run in a cluster, or does that vary as well?
So we've evaluated XDCR a couple of times in earlier versions where it wasn't as stable. Now that it's getting more mature, we'll probably go and revisit that again. One thing that's sort of interesting for us is how far can we push the bar with it, because there are some clusters that are getting closer to 100,000 QPS, and can we replicate that in or a good a reasonable time without data loss, etc. And what was the second question about replicas?
Yeah, just how many?
Yeah, so generally it's just one replica that sort of fits our use case.
So, looks like this is caching and read scaling kind of use cases. So, do you have copies of data in like Oracle or some other data store?
Yes, we do. So we have sources of truth that are in Oracle. We have something called Espresso, which is something that we built internally. We have Voldemort, which is something we built internally. And so we have a whole bunch of data stored in a whole bunch of different systems, both internal and external, and Couchbase is part of that ecosystem.
So Couchbase is not a source of truth?
Not currently.
For these caching situations, no. No, it's serving as the caching, the read scaling layer.
So you mentioned about like MapReduce job, which is running from the source of truth and right into the cache, and then you flip back and forth to the clusters, or?
No, so our Hadoops actually don't operate on source of truth. They operate on copies of the source of truth at some point in time. So They're basically all done offline.
So your cache is how much behind from the source?
It depends on what our ETL times are. Probably, usually about a day or so. But it's pretty easy for us to catch up a day. Whereas if it were, weeks or months, sometimes it would take a while.
If the application which is looking for a data which is not there in the cache, so the source of truth.
Yes.
It's like kind of a, then you get like a pass-through thing, or?
So we have different models, and we let the developers determine which model they want to use. They can replicate the data in the cache. They can use the cache as a write-through cache. They can use it as a read-through cache. It's up to the developers on how they want to do it, but we support all of them.
So one of the main uses of Hadoop, I work at LinkedIn is also, one of the main uses of Hadoop is for catastrophic recovery. So like you said, you get a load hundreds of millions of records back into Couchbase. It's hard to do from the database. We have a Hadoop job that'll generate it in like 30 to 60 minutes and load it in Couchbase. So we can get back up and live within a couple hours instead of a week to load it all.
The disaster sort of scenarios that Couchbase gives us, it gives us a lot of flexibility and a lot of reassurance that, given some sort of degraded state, we can either have sort of no impact or very low impact, which is very, very comforting.
So it's all about being able to sleep at night, basically.
Yeah, we do similar thing. That's why I'm checking with you. That
yes.
Is it like you do active and standby? So if you're loading in another standby, so you have up to date, and then you back and forth, the application can read from either of the cluster.
Yes. So do you want to? Pretty much, yeah. It's very similar to that.
Yes.
Yes.
Did you use views much?
So the question was, do we use views? Not at this point in time. There are a couple of SREs sort of looking at that for their own personal projects. There are particular SREs that sort of like Couchbase because it's sort of a very flexible store. You don't need to have a schema per se. So for us who don't sort of work in a completely structured development environment, it's good, and you sort of get some of that NoSQL. Some of the SQL-like things in a view, but you still have the flexibility of a NoSQL store.
So I should say at LinkedIn, a lot of these personal projects become our production projects.
Yeah.
So it's a very, if something works and works very well, we use it.
Yeah.
Well, the reason I was asking that, if you're thinking about it, is at least up to, I guess, pre-3.0, the views don't get re-indexed until the data hits the disk, and whether that latency would cause any problems with data sets as large as yours.
Right. So for the caching scenarios, we operate mostly in memory. So for those, we do not use views.
We sort of haven't hit that use case yet. Like we will, if we ever sort of come to that scenario, we try and field test it ourselves as a virtual team first, or at least work with the team doing that, so we can go and test that, in staging, so we don't sort of have any production problems.
So you mentioned you have multiple clusters.
Yep.
Was it a decision because of the application doesn't need more than that, or it's like not having a good idea to have more than certain size of the cluster?
So some, as Carleton said, some services have multiple clusters. It just depends on their use case. We're sort of very much against sort of having a massive centralized store, just because it sort of becomes more difficult to operate because you've got so many different things talking to it. If I need to go and make a configuration change on the application side, I've got to go and deploy that configuration to X number of servers, and at our scale, that's pretty large and it's time consuming. So sort of breaking up clusters sort of also reduces your fault domain, which is something that's really important to us. So thank you very much, everyone, for coming. Hope you enjoyed the conference, and thank you for coming to our talk on LinkedIn.